Good morning students. So today we are going to see the chapter 2 of unit 1 number system. Okay. So in the last video we have learnt about the chapter 1. So what are all the generation of computer, components of computer, and then you have learnt the input devices, output devices and booting process. Okay. So these are all included in the first chapter. So the second chapter is the number system. So it will be as mathematics class. So don't be get very afraid or something, it will be simple mathematics. So this is nothing, the number system. So what are all the number system we are using? Okay. So we know the number system, we will say 1998. So this is the decimal number system. In day to day life you are using a number system now from 0 to 9 digits, that is decimal number system. Other than that, what are all the number system available? Okay. Available. So first one, in what is the language the computer can understand? So it can understand only zeros and ones. Okay. So the computer can understand only zeros and ones. So these zeros and ones are called bits. Okay. That is, they are only two values, and that is binary digits, that is bit. Okay. So the 0 and 1, these two are only understandable by the computer. So zeros and ones are called bits, that is binary digits. Okay. Binary, that is bit, binary digit, by, and this here t, that's t. Okay, that is bit we say. Okay. So zeros and ones, that is the 1 bit means 0 is 1 bit and 1 is the another bit. Okay. So 4 bits will be equal to 1 nibble. Okay, 1 nibble we say it as 4 bits, and 8 bit is equal to 1 byte. Okay, 8 bits is equal to 1 byte. Okay, so zeros and ones are binary digits, that is bit, 4 bits is equal to 1 nibble, and 8 bits is equal to 1 byte. Okay, so and next comes the kilobyte, KB. Okay, so the kilobyte means 1024 bits, we say it as 1 kilobyte. Okay, 1024 bits is equal to 1 kilobyte, that is 2 power 10. 2 power 10, that is we call it as 1024, that is equal to 1 kilobyte. In the same thing, there are many updated version for the bytes also. Okay. So you will be now using the pen drive, you will say it as 4 GB pen drive, 6 GB pen drive. What does that GB mean? That is the gigabyte. Okay. So kilobyte, and next comes the megabyte, and next come the gigabytes. So when you are using hard disk, nowadays we are to load many videos and photos, we are having the hard disk, secondary device hard disk. So it is measured in terabytes, TB, is it no? So these are all, they includes this type of bits. So 1024 bits is 1 KB, so it is the 2 power 10. So next comes gigabyte, so that is 1024 kilobyte is 1 GB, and next come 1 megabyte, and next come GB, and next come 1 terabyte, and next 1 petabyte, 1 hexabyte, and 1 zettabyte, 1 iota. Okay. So this is 2 power 10 is 1 kilobyte. So megabyte is 2 power 20, and here 2 power 30, and terabyte 2 power 40, peta 2 power 50, hexa 2 power 60, zetta 2 power 70, and iota 2 power 80. Okay. So this is all the measuring units. Okay. So first bit means binary digit. Okay, zeros and ones, 0 is 1 bit and 1 is another bit. So 1 nibble is equal to 4 bits, and 1 byte is equal to 8 bits, and 1024 bits is equal to 1 kilobyte, that is 2 power 10, and 2 power 20 this 1 megabyte, 1 gigabyte, terabyte. So now what is the value of 1 gigabyte? That is 1024 megabyte. Similarly the next one, 1024 gigabyte. Okay. So that is 2 power 10, 2 power 10 is 1024. So it goes on increasing, so and it is the value. So, in one verse they will be asking this, okay. 2 power 20 is equal to what type of byte it is. So, 2 power 20 means 1 megabyte. So, 2 power 50 means 1 petabyte, okay. So, be clear about this. So, this is the bits. So, the computer can understand only the machine language, zeros and ones. So, it has been represented in bits, and next week when days go on, we came to know about the megabyte, gigabyte, terabyte and so on, okay. So, next we are going to see the types of number system. So, there are different types of number system. So, number system, first one decimal, and next binary, octal and hexadecimal. Okay, so these are all the types of number system. So, decimal, binary, octal and hexadecimal. So, decimal is the common one we are using. So, each number system has their own base value or radix. Okay. So, base value means, so here in decimal we are using the digits 0 to 9, isn't it? So, when it comes 10, it is 1 and 0 belong to the digit 0 to 9. Okay. So, 0 to 9 digits only, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, among these number, when they get repeated only, we form another number. Okay. So, the digits included in decimal is 0 to 9, 0 to 9. So, this is it has the base value, it has 10 values, 1 to 9 plus 1 0. So, it has the base value 10. We can say it is base value or radix. Okay. So, as it has 10 digits and it has a base value 10 or its radix is 10, we can say. In binary, they are having only two values, 0 and 1. Binary means by, that is only 2, that is 0 and 1. So, it has a base value or radix as 2. Okay, binary number system has a base value as 2, and octal, here you will be having 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0 to 7, that is octal means oct 8. So, in the same thing, it has the radix 8, but it has the digit from 0 to 7. It has the digits from 0 to 7 and its base value or radix value is 8. And next comes the hexadecimal, that is from the name itself you can know, decimal means 0 to 9, hexa means 6. So, after decimal you are having 6 values, that is entirely you are having 0 to 9 and A to F, that is its base value is 16. Okay. Decimal means 10, hexa means 6. So, it has a radix value or base value as 16. So, the whatever the digits included is 0 to 9 and A to F. What does it mean A to F? So, 0 to 9, then 10, 11, 12, 13, 14, 15. So, 10 is represented for A and B for 11, C for 12, D for 13, E for 14 and F for 15. Okay. So, these are all the alphabets for the particular digits 10 to 15. So, the base value of hexadecimal is 16, 0 to 9, from 10 we are representing in an alphabet A to F. Okay. So, 6 characters. So, in hexadecimal the base value is 16, for octal it is 0 to 7, the base value is 8, and for binary it is the zeros and ones, then the base value is 2, and for decimal it is the base value is 10 and the digits is from 0 to 9. So, first you must be very clear about it. Okay. So, let me write some 5 numbers, try to find out from which number system they belong to. Okay. 764, it can be what type of number it is? 764. Okay. So, 4, 6 and 7. each number will be belonging to the decimal number. Okay. Whether it will belong to binary number? No. So, whether it will belong to the decimal number, and for decimal number each and every digit, that is digit means this particular 7, 6 and 4, this is the digit, isn't no. So, each number must be belong to 0 to 7, any one of that. Does it belongs? Yes. 7, 6 and 4 belongs to 0 to 7 only. So, it can be a decimal number and it can be an octal number. Okay. And then, so 7, 6, 4. So, generally we do not mention the decimal. So, you represent as octal 764. So, what will be the base value? 8. So, this number, what will be the, which type of number it is? 1001101. So, it has only zeros and ones. So, it is belong to the binary number, and the binary number has a base value 2. The base value must be represented like this. Okay. So, 2, and then the hexadecimal, suppose 215. Okay. So, you should not represent, if 215, if I write it as 215, then it will belong to an octal number, isn't no. So, instead of considering, but I have mentioned as 15, but when someone read it, they will read it as 215. So, they do not know, they will not give the correct answer. So, instead of writing 15, we will write it as the alphabet F. So, that is why in hexadecimal from 10 to 15 we are representing them in characters. Okay. So, 2A. So, what type of number is this? So, it is the hexadecimal number, and what is the base value of it? The base value of this is 16. Okay. Suppose I am having 985. Then it belongs to 10, because 9 is not included in binary or octal. So, 985, then it is the decimal number. Okay. I think you will be clear about the 4 types of number system. So, zeros and ones only means it is a binary number. Within 0 to 7 means it is an octal number, and hexadecimal means from 10 to 15 we are replacing them with the particular alphabets, and next 985 it is a decimal number, it is from 0 to 9. Okay. In this second chapter you have learned the types of number system. You will be learning how to convert from one type of number system to another type of number system, from decimal to binary, decimal to octal, decimal to hexadecimal, binary to decimal, octal to decimal, hexadecimal to decimal, and within this binary to octal, octal to binary, same thing. Okay, like this. You will be learning the conversion of one type of number system to other type of number system. That only we will be learning in this second chapter. Okay. So, for that you must be very clear about this basic 4 types of number system. So, binary means zeros and ones, octal means 0 to 7, decimal means 0 to 9, hexadecimal means 0 to 9, and from 10 to 15 you will be having the alphabets from capital A to F. Okay. So, next we will see the conversion. So, now we are going to see the conversion of one type of number system to other type of number system. So, first let us consider from decimal. So, decimal to binary, decimal to octal, and decimal to hexadecimal. Okay. So, the decimal is the common number system we are using. So, from this how we can convert the number to binary, how we can convert the number to octal, and how we can convert the decimal number to hexadecimal. Okay. So, in this, while converting this we will be using the base value of them. So, what is the base value for a binary number? So, for a binary number the base value is 2. Okay. So, consider an decimal number. Consider a decimal number as 75. Is this a decimal number? Yes. So, 75 is a decimal number. So, now we are going to convert it into an binary equivalent. Okay. So, 75 to the base 10. So, when you want to convert it to binary, you must use the base value of it. What is the base value of a binary number? A binary number has a base value 2. So, first you should divide by 2. So, 3 2s are 6, 15, 7 2s are 14 and the remainder is 1. So, the remainder must be noted for each and every division at the right hand side of it. Okay. So, 75 when divided by 2, 37, it has a remainder 1. So, I am mentioning in the hyphen and then I am mentioning there. Okay. And next I have to divide it by 2. So, 2 1s are 2, 17 means 8 2s are 16 and the remainder 1. Again 2, 9 2s are 18. So, here I am not having any remainder. So, I must specify it as 0. And 2, 4 2s are 8, here also no remainder. And 2 2s are 4, no remainder. 2 1s are 2 and no remainder. Okay. Here you must be having either 1 or 0. Up to that you have to divide it. Okay. So, again you cannot divide, 1 cannot be divided by 2. So, with this you can stop. So, if you want to convert a decimal number to binary number, you must divide the decimal number by the base value of binary number, that is 2. So, 75 when divided by 2 will be getting 37, the remainder 1, and then 18 2s are 36 and the remainder 1. So, if you are not having any remainder, then it should be specified as 0. So, if you have 0 as a remainder, it should also be mentioned, okay, here as 0. So, 4 2s are 8, no remainder, 2 2s are 4, 0, 2 1s are 2, 0. And then when you are writing the answer, you must write from here. Okay. So, you must write the answer from here. So, the 75 equivalent 10, that is 75 is a decimal number. So, it has the base value 10. It's what is its binary equivalent, that is the base value 2 is 1. How many 0? 1, 2, 3, 4. 1, 2, 3, 4 zeros and then 2, 1. Okay. So, this is the binary equivalent for the decimal number 75. Clear? Okay. So, if you want to convert a decimal number to binary, then you must divide it by the base value of binary, that is 2, and then you must mention the remainder on the right hand side. If it has no remainder, that is if it has 0 remainder, it must also be mentioned. Okay. And while writing the answer, you must write from here. Okay. So, this is the equivalent. Suppose if this is the same number, decimal number, if you want to convert it into octal. So, what is the base value of octal? That is 8. So, when you are dividing by 8, so 75 when divided by 8, what will be the value? So, 9 8s are 72. 72. So, what is the remainder? 73, 74, 75. Therefore, the remainder is 3. Now, what is the remainder? The remainder should be mentioned here. So, again I am dividing it by 8. 8 1s are 8 and the remainder is 1. Clear? So, if you want to convert a decimal number to octal, then it must be divided by the base value of the octal, that is 8. So, 8, 9 8s are 72, remainder 3 should be mentioned on the right hand side, and when it again divided by 8, 1 8s are 8 and the remainder is 1, it is also mentioned. So, 1 cannot be divided by 8 further, so we stop here. Okay. So, this is, and here also you must write the answer in this. So, 75 to the base and a decimal number is equivalent to its octal 113 to the base 8. Okay. So, suppose if you are going to find a decimal equivalent into hexadecimal. So, if you want to convert a decimal number into a hexadecimal, then you must divide the number by 16. So, let us have the same number 75 when it is divided by 16, that because hexadecimal has the base value 16. So, how many times in 75 it will go? So, 4. So, 6 4s are 24, 2 remainder, 4 1s are 4, 2 64, 16 4s are 6 4s are 24, 2 64. So, what will be the remainder? 1 11. So, 4 remainder is 11. Okay. So 75 when divided by 16, 16 fours are 64. So 75 minus 64, there is 11, remainder is 11. Okay. So now what is this hexadecimal equivalent? So 4, what is the alphabet for 11? For 10 it is A, and for 12, for 11 it is B. Okay. So 4B. Okay. So 75 to the base 10 is equal to 4B to the base 16. Okay. So when a conversion of a decimal number system to binary, octal and hexadecimal. So the basic number system is decimal. So from a decimal number system, we are going to convert it into the other type of number system, binary, octal and hexadecimal. So for binary means it must be divided by its base value 2 and the remainder must be specified on the right hand side, and we are writing the answer, it must be returned from the lowest bit to higher bit. Okay, from here it must go. And next, from converting a decimal to octal, it must be divided by 8, and this is the answer for this. And for when you are converting into hexadecimal, it must be divided by 16. So if the remainder is 11, then the particular alphabet up to 9 means you can specify as it is. From 10 you have to specify it as A, for 11 B. Similarly for particular number you must specify the particular alphabet. Okay, A to F. So here for 11 it is B. So therefore for 75 its binary equivalent is this, its octal equivalent is this, and the hexadecimal equivalent is that. Okay. So today we have learned the 4 types of number system: binary, octal, decimal and hexadecimal, and we have learned the conversion of decimal number system to binary, octal and hexadecimal. In the upcoming next chapter, next video, we will be seeing the conversion of the other number system from binary to decimal, octal to decimal and hexadecimal to decimal, like that. Okay. So thank you students.